All right, so let's talk about graphing with this number line, what it is, why does it work, and why do we use it, how is it helpful. So when I look at the example that I picked out here, I picked out a pretty easy one just so we don't get hung up in the specifics of all the other stuff, right? But first thing, always still going to be the same. Find my x-intercepts. So I set my numerator equal to 0. So in this case, I get x equals -4. So I go over here to my picture, place a dot at -4. Perfect. Next thing, I'm going to find my vertical asymptotes, which is just where is my denominator equal to 0. So I get x equals 2. Come over here to +2. Draw my vertical line. We're going to pretend like that's vertical because it's not, but whatever, right? Now for my horizontal asymptote here, right, because my degrees are equal, I'm going to use the ratio of leading coefficients. And so for this one, it's got to be just the 1x in the numerator over the 1x in the denominator. And I'm perfect. I'm ready to go. Right, so this is the point now where I'm going to make that number line to help myself and try and figure out what does this picture look like. So on this number line, I just put my x-intercepts and my vertical asymptotes. Now the reason why, the whole idea of this whole thing is that if my graph is going to change sign, at some point it was either 0 or I had a break in the picture like this vertical asymptote where stuff flips over to the other side because of that symmetry that I have. So the idea is if I test a point, just a single point, any point, in a given interval between where there are those x-intercepts or my vertical asymptotes, whatever that sign is has to be the sign over the course of the entire interval. Because if it was going to change sign again, if something else was going to happen, well, at some point it would have to be 0 again, and I would have another x-intercept. So here, for this number line, to the left of -4, right, let's just say I picked a number like -10, right? So for this side, I'm going to use x equals -10. When I plug that into my function, I get -10 plus 4 over -10 minus 2. Well, that gives me a negative over a negative, which means to the left of -4, that must be positive. And actually, you know what? Let me color code this. Maybe that will make things a little bit easier here, right? So if I change this, let's make this part blue. It must be positive there. So what that means on this picture is that part had to be above the axis somewhat, in some way, right? Maybe it's not that steep. Maybe I kind of goofed a little bit. Right? Maybe if I make that a little bit shallower, something like that. Now between, well, maybe I'll use green for this, between -4 and 2, well, I'm just going to use 0 for this one. 0, come on. There we go. Right, when I plug that in, I just end up with 4 over -2. Okay, well, it's going to be negative here. So on my picture, what that means is this part now is going to be below the axis as it approaches that vertical asymptote. Right, and so for above the +2, let's say, I don't know, maybe I'll use blue, I'll use pink. We'll use that, right? If I pick any number, it doesn't really matter, right? So let's say I picked +10. Well, I end up with 10 plus 4 over 10 minus 2. Well, that's a positive over a positive, which means that part is positive. So I know up here the entire time, it's got to live above both the vertical, or sorry, it's got to live above the horizontal, because in order to be positive, the only way you can do that, right, y is always going to be positive on that interval. So I hope that was helpful, right? But the whole idea of that number line, again, remember, is that if it was going to change sign, at some point it had to be 0 again. Or I had another break in the graph like a vertical asymptote. So that's why those are the points that go on your number line. And the idea with testing a point is that it must be that same sign everywhere. So I hope that was helpful. If it wasn't, let me know. And hopefully, maybe I can come up with something else or a different explanation that helps.